Okay, so let's continue with the query smart contract example. This will be a little bit more complicated. Let's define the main function. Let's define the run function. Run. No, I don't want to panic around to. Okay, good. So, in order to query a smart contract, we need to see the exact input and output. We don't have this in the integration layer, as we only have like a generic we only have like a generic endpoint that from which we can query any smart contract, but it requires some parameters. I will show right now. Okay, so we'll need to go back on the live tree because querying like a smart contract state and information requires like to connect to a node and ask it directly. And here we have this endpoint. It's a pause. This is like a pause request because it requires like a body, and we have the following. Let's copy paste this here. Okay, good. Okay, let's do query smart contract URL. This is v1. This is query smart contract. I think this is it, right? Query smart v1, query smart contract. Okay, yeah. And this is query smart contract payload, request payload, and the response is basically a string. You'll see after that why. I will show you. Okay, so let's talk about a little bit about these fields. Okay, so contract index is an index which is basically the ID of the smart contract, is the index of the smart contract in the Qubic chain. I'll show it in a couple of seconds how to get that. Here we have the input type, input size, and request data. Input type is basically uh, it's basically a mapping to know to direct the request to a specific method call of that smart contract. Input size will be needing to do it manually here depending on the request data and request data. So each smart contract has some functions or methods that you can call. If it's a method that doesn't require any input, request data will be empty, response size will be 0. Otherwise, input size will be the length in bytes of the request data. Uh, we need to keep in mind that request data will be base64 encoded, and as you would expected, also the response from here will be base64 encoded. I will show you why. Okay, so for this example, I wanted to choose like not the easiest smart contract call, but not also the most complex one. I've chosen the QN smart contract, and I wanted this. I wanted the get lock info per epoch method to call on this smart contract. So I'm getting these from the core from the core code base. Every smart contract which is deployed on the network uh, are being the code is being published in the core repository. So I'll also post it here as a comment for you guys to have like a reference. Okay, and I don't want to spend like any time in explaining you guys like what's the structure here of the smart contract code. I'll let this probably this will be covered by the core team. But long story short, we have at the end of the smart contract we have, where is it? Where is it? Ah, okay, here. Okay, so we have this. So the smart contract is exposing these functions and procedures. So we have one, two, three, four, five, six, seven, eight functions, and one procedure. What's the difference between a function and a procedure is that so a function is basically a way to query to get data from the smart contract. A procedure is basically calling and issuing a transaction. So it will also issue a transaction in order to call a user procedure. So as we only want to read data, we have available these functions, and this is basically the let me give you like a quick example. Maybe it's easier for you to understand. Okay, so we have get log info per epoch. This is the function that we want to call, and the input here. This is the input. It's following like the function name suffixed by input, and the output is basically the same but suffixed by output. So in order to call this function, you need to pass the epoch. This is as part of the payload, as part of the request, and this is basically the response. Okay, so let's try to compose first these structs into Go. This is C++ here, so what's in core repository, it's only C++. Let's copy paste those here because we need them. Okay, what did I do? What? How do I do like multi-line? Multi-line comment. I forgot how to do that. This is not how to do it. Sorry for that. This should be the syntax. I think because of these comments, but I am not sure. Yes, this was the problem. Okay, good. So get log info per epoch output per epoch input struct. We don't need a JSON tag here, as we need to send the information. We need to encode it in base64. So in order to encode it in base64, we need to write the binary representation of it. We need the binary representation of it. Okay. So we have locked amount, bonus amount, current locked, current bonus, and yield. Okay. Okay, so we have what we need for request data, which is the input. As this is a new int32, I think the size is 4 bytes. Okay, so this is 4 bytes. The input type, okay, so the input type is the one defined here. Where is it again? Going back to the list of functions. Okay, here. This is the input type. So this is basically telling, okay, register this user function with this name, and this is the input type. This is okay. And okay, let me get the contract names, and after that, I will try to give you like a better one example to better understand like what is this exactly. Okay, the smart contract index. This is defined. 1 second. I think it's should be somewhere around here. Let's go to README. No. API. Okay, it's not here. Let's try to do search here. QX contract index. Okay, it's being defined as QX, not QX, it's QEarn, the name of the smart contract. QEarn contract index 9. Contract definition. Okay, so here for each smart contract I have defined the contract index, which is 9. Okay. And basically you need to search for the name of the smart contract and then contract index. Okay. QRM hash. Okay, good. Okay, so how, in order for you to understand what's this? Okay. So basically, how it is being defined high level in core is that we have defined a function which is called get lock info per epoch. We have the input here, input and output. Okay, this is basically like what we will end up calling in the core node. Good. Okay, so I think now we have all the information that we need. We have this epoch. Okay, good. Now let's proceed in encoding the information. So let's say we want this epoch. So what do we need in order to call this function? If we go back here, we need the epoch, which epoch are we in right now? We are in epoch 167. Okay, epoch. Let's define it as okay. Now we need to encode the epoch in but you need to get the binary representation of the epoch in order to encode it in base64 in order to do it, in order to pass it as the request data. Okay, input binary little Indian append uint32. Let's first define the byte, input bytes, which is okay. This accepts the bytes, the destination bytes, and the epoch. Okay. Now we have the binary representation. We now need to convert to encode it to base64. So input base64 exactly encode to string input. Good. Input size, we said that it's 4, or let's see, input size, is it the same as the slice length? Should be. Input slice of the input bytes. Okay. We have the input type, which is 1. Contract index, which we said that it's 9 for keyword. We have contract index, input type, input size, request data, which is this. Okay. And now let's create the payload. Fill all fields, contract index, input type, input size, and request data. Good. Okay. Okay. And now okay, so I just did this as the input has like only one field, so if the input had like multiple fields, we needed to do like a slightly different approach. This is like the simplest one because it only has one field. So if it had like multiple fields, let's input (167) binary encode, yes, encode this. We need to call this encode. It is returning on int and an arrow. Don't care about int. The bytes, input bytes, binary little endian, and input. Okay. Encoding input to binary. Good. And here, yeah, it's not string, it's input bytes. Good. Okay. And now we have input bytes, payload. Okay, good. This is the generic approach. Okay, and now let's create the request. New request with context. With timeout context background 5 for time that seconds. HTTP method post. Correspond and body. Okay, so we need to create a body. JSON.new encoder bytes buffer dot encode payload. Okay. Okay. Encoding payload. Okay, and here we have the buffer. Why do we have this? Ah, okay. Oh, okay. Sorry. Okay. Buffer. Oh, exactly. Okay. 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 Your requested context request dot do HTTP default client request res error handling. Okay. Okay. The response is, as we already said, is base64 encoded string. So we need the output more query. Where is it? Type query smart contract response struct response data or query response. Okay. Let's decode error handling, decoding response. Response data in the byte representation. We have it here. And then okay, and then we need to do a binary.read response data little Indian output. Yes. And now let's see. Fingers crossed. Return nil. Encoding input to binary. Input to binary. Okay, I know. As exactly, we need to have the input byte slice with a specific length. Okay, input size 4. Whatever. I knew that this would be a problem here. Okay. Okay, we have a winner. Locked amount, bonus amount, current locked amount, current bonus amount, and the yield. This is exactly what we were looking for here. 1, 2, 3, 4, 5. Okay. Okay, so our example is working. Okay, let's take a short break. And I'll take a short break, but yeah, you'll not be seeing anything. I'll pause the video. And in the last example, I will be showing you how to send a transaction.